Okay, today we're going to be talking about solving exponential and logarithmic equations. And we kind of talked about this once already whenever we were solving equations and trying to write them in exponentials. So we're going to piggyback off of that information that we've already learned previously to this. And our goal is to look at each of the bases and we want them to match. So 8 and 32 have a common base of 2. So this is going to be 2 cubed raised to the power of 2x is equal to 2 to the 5th. Then these two right here is a power to a power, which means you're going to multiply those to give you 2 to the 6x is equal to 2 to the 5th. Then you are going to realize your 2's cancel out and you get a 6x is equal to a 5. Divide by 6. Sorry, my board is acting up. Divide by 6, and you're going to get x is equal to 5 over 6, and that is done. So this is pretty easy. This is something we've kind of already done already. But again, your goal is to have the bases be the same. So go to the next one, same exact concept. Look at my bases. I have 36 and I have 216. Well, immediately whenever I think of 36, I think that is 6 squared raised to the power of negative 2x plus 1. And then 216 is actually going to be 6 cubed. So I'm going to multiply these exponents right here to give me 6 to the power of 2 to the negative 2x plus 1 is equal to 6 cubed. From here, my bases cancel out, and I'm left with 2 parentheses, 2 parentheses negative 2x plus 1 is equal to 3. So I'm going to distribute negative 4x plus a 2 is equal to a 3. And I'm going to simply solve for x by subtracting 2. Dividing by negative 4, and I'm going to get x is equal to negative 1/4. Okay? And the last one like this is going to be 9 to the 2x is equal to 27. Again, look at your bases, and we want our bases to have the same bottom, so that's going to be 3 squared raised to the 2x is equal to 3 cubed. So I'm going to multiply those powers, giving me 4x is equal to 3 cubed. I'm going to cancel out my 3's, giving me a 4x is equal to a 3, so x is equal to 3/4. So that makes complete sense to us. So what happens when you can't express the numbers with the same base? In this situation, 48 cannot be expressed as 2 to a power. So what we have to do is we have to somehow get our variable, which is the variable x, out of the exponent position. So that means the opposite of an exponential is now a logarithm. So we're going to take the log of the same base, which is a 2, of 2 to the x is equal to log base 2 of 48. Then, what your brain needs to understand is the log base 2 of 2 cancel out, and I'm left with x is equal to log base 2 of 48. Log base 2 of 48 can be calculated. And what we're going to do is we're going to come over here and we're going to calculate that. And I'm going to refresh my page. And you have got to use the functions. So you're going to scroll about 3/4 of the way down. And when you're about 3/4 of the way down, you're going to get log base A of 2 of 48. You can get over there and hit enter. And you're going to round 2 decimal places. So that's going to be 5.58. So x is equal to 5.58, and that is done. Why did I have to do it like this? Because 48 could not be expressed as 2 to the same power, okay? So again, same thing. We're going to isolate. So I'm going to isolate this. And hopefully I can get my highlighter tool, and apparently I cannot. So we're looking at this right here, and I'm going to divide by 3. Makes no sense. 2 to the x is equal to 42 divided by 3 is going to be the value 14. So 14 cannot be expressed as 2 to a power. So I'm going to look at this base, which is a 2, and I'm immediately going to take log base 2 of 2 to the x is equal to log base 2 of 14. What you do to one side of the equation, you must do to the other. And then your brain is going to recognize that those cancel out, and you have x is equal to log base 2 of 14. So I come back over here to Desmos. I come down to functions, and I scroll 3/4 of the way down. I get log base 2, arrow over there, and type 14, and go 2 decimal places. That is a 7, so I round up to 3.81. So x is equal to 3.81. And that is done. Okay? Again, next one, we're going to isolate. So the very first thing we're going to do is we're going to add 3 to both sides. So if I add 3 to both sides, I have 4. E to the 2x is equal to 5. From here, I'm still isolating my exponential, so I'm going to divide by 4. E to the 2x is equal to 5 over 4. Now, I cannot write 5/4 with a base of e. So I have to make this log base e of e to the 2x is equal to log base e of 5/4. Now, we have a problem. We never use log base e. Log base e is the natural log. The blue is the correct way to write this. This is incorrect, okay? But I wrote that there so your brain understands it. So now, e and the natural log cancel out, and I have 2x is equal to the natural log of 5 over 4. This right here is just a calculation that you will do in Desmos. I need to solve for x, so how do I do that? I divide by 2. So x is equal to the natural log of 5 divided by 4, and all of that number divided by 2. So I come over to Desmos, and I go to Functions, and I scroll halfway down, and there I want ln. ln of 5 divided by 4, and then all divided by 2. And I hit enter, and I'm going to go 2 decimal places over, so that is going to be 0.11. And that is done. Okay? Same concept. So now I need to do the natural logs. So I've done a whole bunch of exponentials with you. Now I'm going to give you natural logs or logarithms. When I see natural log, my brain needs to say that that's log base e of x is equal to 2. I need to immediately rewrite this as an exponential function. So my base is e, my power is 2, and that is equal to x. I can calculate that by coming over to Desmos and simply typing e raised to the 2nd power and hit enter, round 2 decimal places, and that is going to be 7.39 is equal to x. Okay? Same thing. So what are we going to do here? I'm going to isolate the logarithm by subtracting 5. So 2 times the natural log of x is equal to -1. Divide by 2, and I have the natural log of x is equal to -1/2. Now, this is a natural log, so my brain needs to understand that this right here is the same thing as log base e of x is equal to -1/2. And now I need to write this as an exponential. So that is e to the -1/2 is equal to x. I come back over to Desmos, and I type in e to the -1 divided by 2, and it pops out, rounding 2 decimal places, 0.61 is equal to x. Last one, same exact thing. We're going to isolate the logarithm. So if I'm isolating the logarithm, I'm simply going to divide by 2. Log base 5 of 3x is equal to 2. Then I'm going to write this thing as an exponential function. My base is 5, my power is 2, and that is equal to 3x. What is 5 squared? It is 25. How do I solve for x? Divide by 3, and I'm going to get 25 over 3 is equal to x. Tonight's homework is going to be 7.5 worksheet 1. And we're going to go ahead and start that now. Okay? So number 1, it says use the properties of logarithms to evaluate each expression. So this is kind of what we did yesterday, so we're going to condense this. and we need to evaluate this. So how do we go about that? Well, the way we go about that is in log world, what is addition? In log world, addition is going to be multiplication. So this is log base 2 of 8 times 4. 8 times 4 is 32. And how do I rewrite 32? 32 is going to be 2 to the 5th. So that means these cancel out, and it is just a 5. Now, there's multiple ways to do this. If your brain went ahead and said, okay, well, I want to redo this and make this as log base 2 of 32, and then set that equal to x. 2 to the x is equal to 32. 2 to the x is equal to 2 to the 5th, so x is equal to 5. Both methods get you exactly the same answer. Okay, number 5. Now, what you need to understand about these is they have exactly the same base. So since they have the same base, I can go ahead and marry these two, making this 36 times the square root of 6 because they are attached by addition. So that means multiplication. Okay? So now I'm going to set this thing equal to x. So that means I'm going to write this logarithm as an exponential. So that is the square root of x to the power, or the square root of 6 to the power of x is equal to 36 times the square root of 6. Okay, well what our brain does not like is the square root. So that's the power and that is the root. So we're going to rewrite this as 6 to the 1/2 x is equal to 36 is 6 squared. The square root of 6 is 6 to the 1/2. Now, these two are attached by multiplication, which means I'm going to add those exponents. 2.5 is the same thing as 2 times 2 is 4 plus 1 is 5 over 2. So here, I can cancel out those bases, and I have 1/2 x is equal to 5 over 2. Now I'm going to simply solve for x. I'm going to multiply both sides by 2. X is equal to the number 5. Next, number 10. The directions say solve each exponential function. So our goal is to have each of these bases have the same base to a power. So 2 is already in its most simplified form. So that means I'm going to have 2 to the x is equal to 2 cubed. Yes? Cancel those out, so x is equal to 3. Next, number 14. Isolate. This is what we're isolating, so we're going to subtract 8. So I'm going to have 10 to the x is equal to 1,000. So now, how do I rewrite so that my bases are the same? Well, 10 is going to stay, but 1,000 is 10 cubed, which means x is equal to 3. Number 17. Number 17. Well, I now have a logarithm base 5. So we are going to go ahead and we're going to rewrite this as an exponential. My base is 5. Go across, grab the exponent, and that is equal to the chunk of 2x plus 5. 5 times 5 is 25, times 5 is 125, is equal to 2x plus 5. How do I solve this? Subtract the 5, and I get 120 is equal to 2x. Divide by 2. And you're going to get 60 is equal to x. Okay? Number 21. Okay? You see 2 logs here. So since we see 2 logs here, we are going to go ahead and we are going to condense this. So the very first thing I'm going to do is I'm going to put the 2 back on as a power. So that's going to be log of base 10 of x squared plus log of 4 is equal to 2. Then I'm going to go ahead and understand that that plus in logarithms means multiplication. So log base 10 of 4x squared is equal to 2. Then I need to understand that this is a base of 10, which means I'm going to write this as an exponential. 10 squared is equal to 4x squared. What is 10 squared? I'm really sorry, my board is acting up. A lot. Like a lot. I'm so sorry. So 100 is equal to 4x squared. Divide by 4. And you're going to get 25 is equal to x squared. And then you are going to take the square root of both sides. And when you take the square root of both sides, you put plus or minus. The square root of 25 is 5, and that's what x is equal to. And the last one is problem number 22 I want to do. So we're going to go ahead and see that this is already a logarithm. And we're going to go ahead and write this as an exponential. So x to the 1/4 is equal to the square root of 7. So now I'm going to go ahead and make this, the square root of 7, become 7 to the 1/2. Now you're going to look at these denominators and you're going to take the LCD. What is the LCD between 4 and 2? The LCD between 4 and 2 is going to be 4. So you're going to raise both sides to the power of 4. The 4's cancel out here. I'm left with an x. 4 and 2 cancel out to give you a 7 squared. And what is 7 squared? 49. And that is section 7.5.